I built a pipeline to figure out what questions people are asking, what people need help with, and really where all the confusion is. This scrapes from YouTube, Maven, X, and GitHub, and it compiled about 6,000 questions for me after some filtering, and that lets me take action. This talk is going to talk about how I did that. I created over 6,000 questions, but not all of those are good. Even if they are good questions, some of them aren't my area of expertise, and some of them I think already have very good solutions and information. Not all of them are questions I can answer. I don't know everything in AI, and some of the things that are asked, I may not know the answer to. Now, sometimes that means I should do some research because I don't think there's a good answer being shared publicly. And sometimes it's just outside the realm of what I'm focusing on. And finally, once you have a question, it's not always clear what you should do with it. Should I build a little agent skill to help people? Should I build an app or a system or a library? Should it just be a tutorial? This gives one of those paths for me, and I'm going to go through the technical details of it. So, of course, first I need the source material. I mentioned I got Maven, X, YouTube, and GitHub, and I got quite a lot from each one. So from Maven, I look at all the top lightning lessons, and I get time-stamped transcripts. These are from Assembly AI. From X, I'm choosing accounts that have interesting information or interesting discussions around them, and I'm using the reply threads to see what people are asking about. In YouTube, I'm doing similar to Maven. I've got transcripts, but I've also got comments, so people can actually ask questions. And for GitHub, a lot of times issues and Q&A are really great sources of questions. Even if it's not a question, if it's a feature request, it speaks to something that people need. All of this gets put in one SQLite table, so I can look at all of them. I have some brand guidelines to choose sources, and I use a rubric to review questions. I'll show some of the annotation process later. In general, I choose the sources, and these are going to be from lessons, repos, accounts, channels that I've chosen. I get exact questions. I get the original source, but I also clean them up for my view. And I get both questions from people and then implied questions from the person creating the material. I've found that the implied questions are generally not very good. Those haven't been nearly as interesting as the questions that people actually ask themselves. And then I have this review questions where I have a little bit of a test. I do it, the element as a judge does it, and that allows me to choose and filter some of these down. So let's walk through some of these sources. So the Maven transcript, it was one of the first sources, and I take a talk, maybe it's on retrieval, and I get this transcript, and at the end there's often a Q&A. And so in this Q&A, someone might say, what about tables of data? How do you search that? How do you index tables? And I'm going to save that exact snippet, but I'm also going to save a question. How should a retrieval system search and index tables extracted from documents? And so the source, the context, and the timestamp are all saved together. I also go from AI GitHub repositories. So like Dockling does a lot of OCR stuff, and there's LangChain and Llama Index and Ragatui. And then from agents, there's Pedantic AI and OpenAI agents. And there's also evals and DSPy and all kinds of repositories where I'm looking at the issues to see what are the problems people are facing that they haven't been able to solve that they needed to open an issue for. So, for example, how should chunking keep tables as separate retrievable elements instead of merging them into the surrounding text? And we can see that came from this particular issue. They didn't exactly ask a question, but they said, hey, it doesn't support this, and they need it. And going through this thread, you can see that someone said, hey, our metrics indicate it produced noticeably better recall when tables had captions. Can you say more about why you need table elements to separate? For X, I choose user accounts. So I go through those accounts. I keep the really active posts, the ones with lots of replies, and then I go through the conversation threads. So these are accounts like Swix or Simon Willison and Jason Liu, Hamill, Ben Clavier, Shreya. All of these are been great sources. It's not always straightforward. So I actually do some transformation. So I get a question and I don't just answer it how the question is. I'm not trying to figure out how do other people talk about this topic so I can say the exact same thing. I'm just trying to find the questions people are asking so that I can answer them. So here's an example of that. Hamill had a post, what happens to AI when forward deployed engineers leave? And so this is really about consulting. And in there, people talked about, hey, the client needs to be able to change a rule, run evals, inspect traces, approve changes, and roll them back. And while I'm probably not going to talk a lot about consulting, this idea of let's separate the forward deployed engineer who's building it from the client who's maintaining it long term got people to highlight some of their thoughts on what those are. And so where should prompts, evals, context, and corrections live? What change? eval, approval, and trace, and rollback flow should the client control. Understanding of what people think or don't know about what they need to do long term that can be used to talk about agentic systems or building AI products in general. It's not even necessarily going to be answering the exact question in the exact context that people asked. I also get YouTube transcripts and collect comments. So use a YouTube DLP that gets a video list of subtitles, and I go through the comments, any of them that have questions. And Codex will find both implied questions, which I told you tend to not be as good, as well as actual questions that people are asking in the comments. So these transcripts can become questions. And this would be an example of an implied one. Now, in this case, what are some strategies we can have to make the most out of the context window? I don't feel like I want to talk about how to use AI for coding a lot. When I did a course on AI coding last year, and at the time, using AI for coding wasn't nearly as accepted. And then since then, in the December and January timeframe, it really took off, and everyone is talking about AI for coding now. So I feel like I don't need to anymore. And I would take this and say, oh, we need to manage the context window. What are some tools that can help an agent do this? So if I'm building a product, how can I build this to help users do this? Once I have these, I just have 6,000 questions. I have to do something with them. I can't look at 6,000 questions, or I guess I could, but it wouldn't be the best use of my time. So I need to normalize and group the questions. So the key of this is every single source is going to write to the same table row. I have verbatim, which is exactly what they said, who's asking it and why, what's the context around that, as well as the source. So I can jump to a timestamp or a URL, and this comes from Maven and GitHub and X. They all go to the same place. Similar questions are grouped together. If I see that only one person has asked about extracting tables from PDF, that's very different than seeing that hundreds of people have asked about this across many channels. And if I see that across all the channels and hundreds of people, then it's, do I build a library for it? Do I build a tool? Do I build an app for it? Do I just help educate people and decide what to do with that? I'm using Mixedbread, and it turns each question into an embedding. I use cosine clustering. I'm going to group all the questions, everything kind of near the same centroid, close together. Then I do manual inspection, and now it's evolving into an LLM as a judge, which I'll talk about here in a minute. And I do see similar questions across platforms. First was like, how do I get the table out of a PDF? And then once it is in PDF, or if it originally wasn't in PDF, was in Markdown, how do you make sure that you're not going to chunk in the middle of a table? I look at both those sources together rather than looking at all the Maven stuff and then looking at all the GitHub stuff. And so I review the questions. So the question might be, how should tables be represented before retrieval? And so I have the source wording the failure, and I'm going to click good, maybe, and bad. I've never looked in the maybe category, but it helps me make a decision quickly. Sometimes I look and I'm like, I don't know, maybe I could talk about it. I'm thinking about it. I say, oh, cool, I had it in the maybe pile. I'll come back to it later. I never have, but I might someday. And that lets me move on faster. And I just focus on the good. And I'm looking for things like, hey, is there a real system decision that I'm going to make here? Is there a particular failure mode that I could talk about? How would I choose? Do I know how to choose between different options? How does it change the design of the system? And does it apply to a real AI product? It doesn't have to have all these contexts. The point is, I want something that I can talk about that has all of these elements. And so a question might ask about a system decision, but not apply to a real AI product. But I might have worked on a project where this decision came up. In this case, I say, oh, this is great. It's a system design decision. I know how it applies to a real AI product because I've worked on that kind of problem. And so I can put it all together. And that's what I'm looking for. If I hear a question and the context contains all the information that I think is relevant, and it's, wow, that's got everything, then I don't need to just say it again. I'm looking for things that are missing information. This is the annotation app that I use. I have various ways of filtering it over here, and I can look at the good, I can look at new, again, the maybe and bad. So I get this question, how can a RAG system chunk tables? So I say, oh, that's interesting. Here's the verbatim. Okay, what is the context of the person asking? Here's the source. And so I can click through and I can look at it and I can see the question. This is what another one looks like. Turn the expert bottleneck into a product architecture. So here we have a problem. Tyler is the bottleneck in agent builds. He wants to extract his forward deployed process into prompts. And the consequence is the product gives non-experts access to expert architecture judgment. And then this is the clip. I can load the clip so I can watch the exact context. In this case, this is from Maven. And so I look at this and I say, "Oh, you know what? Why is this good?" I don't really care about the forward deployed process. That's not really what I want to talk about. But I see this and I say, "Oh, this is interesting because this is something that I see over and over as a big failure mode for building things." What he did is he had a process and he built this process around himself. And then from that process, he started slowly building out an automated system with an agent. In this case, Tyler was the domain expert himself. But if you're building a legal solution, the first thing you should do is you should shadow a lawyer and say, let me just watch what they do. And start with this idea of we have a process that we do a painful way, and let's do that and then build an automated system from that. And that's my take, not about forward deployed engineers. I'd probably apply it to legal since that's what came to mind. And that's the idea that I'd like to talk about. Now, I label these as good and bad. There's also a text field where I put in notes, and my labels and notes improve the judge. So I started off by just manually annotating. I look for clear, obvious misses, then I review them, mostly the good and the bad, and my notes are going to explain mistakes. Now, sometimes it's very obvious. I'm like, I just saw 10 of them, and it's very obvious what the problem is, and I don't need to do this error analysis because I just saw it so many times. It's been so repetitive that I know. And sometimes I need to do more error analysis. And so then I update the judge. When I first got these questions, about 30% of them were ones that I would put in the good pile, things, ideas for me to work on. Now I've gotten to the LLM judge a little bit better tuned. And so about 60 to 70% of the ones I look at end up being ones I want to act on that are good. And so that means there's a lot less garbage that I have to sift through, which is extremely nice. So once I have the question and I've decided it's good, I do need to do some more research, whether it's for a content, a tutorial, a video, or a library. And the way this works is I have a subagent, a child process, whatever you want to call it. I'm in Codex. This is my parent task. I have a research question, and it's going to kick off this child process, which is going to search and compare and rank. It's just going to return the results. This is based off of the AMP code librarian. They have a subagent that does this research that I really like. I think it works really well. And so I made one specific to this. I combine it with some ideas from the RLM paper or Claude workflows or DocETL. All those are getting at similar ideas. And so it combines some of those ideas as well. The way it works, so I have a parent task. It has an agent skill, which has an run.sh, which kicks off the subagent. Right now it was GPT 5.5 medium because 5.6 just came out. I'll probably change it to that. The subagent is going to return the result through standard out, and it also saves a markdown copy, which I can use as context or just reference later. I define this as an agent skill because it's easier to port between frameworks. So it has all the skills, the working method, the report format, everything you'd expect in the skill prompt. And it has a runner. This runner is this shell script that runs a Codex process. And it has routing rules about like when should it use SQL versus a search versus Gemini versus Codex. And it describes the return format that it returns, again, in standard out. It has 5 Python helpers in there. So what the subagent really gets is the instructions. It gets a SQLite connection and read only, and it gets these 5 functions. So SQL for counts and coverage, and it can do pure text search. It has a search function, which is a semantic search over the material that's using Mixedbread, so it can search over videos and transcripts and text. It has this idea neighbors, and this is using the clustering from a given question. What other questions are similar? And it can make LLM calls with Gemini Flash and do that in batches so that it can fan out and find conflicts and find similarities and summarize things. So it writes this as a Python script. And the script might search several ways, combine results and remove duplicates, use Gemini to compare a lot of them in parallel or look for conflict or summarize or combine. And then it uses Codex to rank and write the final output. It often writes a script, gets some output, writes another script. And so it does do an iterative loop rather than a one-time script, but it doesn't have to. SQL is going to count, look for the clusters, look for the dates, like what's recently being asked versus old. Mixedbread is going to try and find similar things based on phrasings. It's also mentioned it's used for cosine clustering. Gemini is going to dedupe and do label and summarize things. and Codex is doing any kind of borderline calls, final reckonings, and the conflict synthesis. It's not on very high effort because I want this to run fairly quickly, but it does a pretty good job. After I figure out what are people asking, what exists, where do the sources disagree, I turn that into a recording plan or something. It might be something else. It might be a library. But in this case, I might record videos off of it based on what people care. This is an example of it. And so I see, when do I add a re-ranker instead of plain vector search? Is late interaction the new default or another stage? And I see recurring conflicts that come up that might need to be answered. So for example, when is naive rag enough? And is late interaction the default or is it a specialist stage? And quality gains versus latency. And all of these are things that I can answer. It also looks across the other data and says, oh, let me look at, because I have a memory store that stores lots of information, and it tries to tie into stuff. It says Ben Clavier had something about strong retriever plus a smart re-ranker. So that's what he recommends. Mixedbread does listwise re-ranking as a candidate set. This was a very new paper. Antoine talks about lay interaction as a middle path. And so these are things that I might want to look into and do some research before I answer. I also see, this is how it recommends I talk about a series. And so I see a deterministic versus autonomous agent parts and the autonomy dial. It says, look, let's show one agent task split. Let's show a real example. Let's score each step. Let's do a dial. And this, to me, is where I start and I say, okay, how do I change this to be grounded in actual information? And it says, hey, here's some examples where this came up, like a refund request. Okay, should a refund request be autonomous, or should that require a human in the loop? Or support ticket routing and CRM deduplication, sales follow-up emails, healthcare intake. And so all of these were examples where people were asking in that context something related to the autonomy of agents. For healthcare for sales follow-up emails, for CRM deduplication, all of these have very different trade-offs. And so I could talk about this autonomous agent in lots of different examples that people are interested in. And here we have extracting tables from documents for AI implementations. And so this is an example with Apple 10K, Tesla annual report, IRS tax tables, a data sheet, a scanned table, an archival manuscript. And so I have all these examples of tables, and I'm saying, how would I get that into text? How would I OCR it? This was the recommendation, and I tweaked this a bit. So I start with just showing the source page. I show, look, here's a basic extraction, like how I'm just going to do plain text PDF extraction. Does it work? If it doesn't work, why? And what's a better option? Show the actual results. I need to actually show what broke and show what fixed. And then I can explain like why I chose this route, when to use it. And so I say, it pulls a text layer and gives text on the left. It's readable, but Dockling gives us the table in Markdown. And it ranges from very simple ones like this Apple 10K and archival manuscripts, which might do VLM. And some of them need Markdown and some of them need bounding boxes. And so each of these follows a very similar structure of show the problem with a basic approach, show a better approach, explain why it's better, and explain why I made that choice. Like, how did I know to do that? So that's my demand signal pipeline. That's one of the ways I choose what to work on, what to talk about. And I hope this was interesting to you. The strongest signal that I have is actually a private AI product engineering community that I run with my friend Hamel. It's a community where people who are building AI products talk. We have multiple live sessions a week, and there's forum posts where we discuss all the challenges that people are doing as they build actual products. If you want more free content, you can stay up to date by following the AI Product Engineering Club newsletter. The newsletter is free, and you're going to get access to a search interface where you can search across many of my talks, many of Hamel's talks, so you can ask questions and you can get it cited to specific videos that are relevant to what you're working on.